Sorry about what happened at the end of the last video. I wasn't paying attention to the time and it ran out. So I just wanted to finish this off really quickly. 11.11 years, if you want to convert that into years and months, then you would take this 0.11, multiply that by 12, and that gives you 1.32 months. And if you really wanted to, then you could convert the 0.32 months into days by multiplying that by 30. Anyway, you get the idea. All right, let's move on to page 3. All right, I'm at the top of page 3. So we just learned about simple interest, and the second part of this lesson is all about compound interest. Compound interest is when the interest earns interest itself. Compound interest, so when interest is earned on interest. So the interest that you earn doesn't just depend on your initial investment. All right, it also depends on how much interest you've earned in, let's say, a year. Then the new year, you get interest on top of the principal plus the previous year's interest. All right, so the formula that we use for compound interest is given right over here. I'm going to put a little box around so you know it's very, very important. In this formula, a equals p 1 plus I to the exponent n. If you remember, it's really similar to unit 4 on exponential functions, where we had the final amount is equal to the initial amount, 1 plus I to the power of n for some of the questions, right? See how it's very, very similar. The a naught is the p, and 1 plus I to the n is exactly the same. All right, a represents the total amount in dollars, p represents the principal amount that you invest in dollars, I represents the interest rate per compounding period, expressed as a decimal always, and n represents the total number of compounding periods. The worth of a compound interest investment can be modeled by an exponential function, okay, closely related to unit 4 on exponential functions. The amounts after each compounding period would then produce a geometric sequence. So see how everything is connected. So we have our unit 4 connection and we have our unit 7 connection. All right, let's go over this example. Mike invests $800 in a GIC. Sorry, GIC is Guaranteed Investment Certificate that pays 4% compounded annually for 5 years. Determine the amount when the investment matures. Matures means at the end of the 5 years, okay, the investment term. So I'm going to use the compound interest formula. A equals P 1 plus I to the exponent n. So P is $800. 1 plus I as a percent, so 4%, or sorry, as a decimal, 4% as a decimal, 0.04 to the exponent 5. If you want, you can write this step and then give the final calculation value. And because we are talking about money, just make sure that you round your final answers to 2 decimal places. So therefore, the investment is worth $973.32 upon maturity. Now, we're going to modify the compound interest formula just a little bit because in reality, compounding periods are often more frequent than once a year. So for example, the interest on some savings accounts is compounded monthly, meaning you get the interest 12 times a year. Okay. The most commonly used compounding periods are listed below in this table for you. So put a little star next to it. You need to know these numbers. So annually means once a year. Semi-annually means twice a year. Quarterly means 4 times a year. So this is every 3 months. Okay. Monthly, 12 times a year. Bi-weekly means once every 2 weeks, so 26 times a year. Weekly means once every week, 52 weeks in a year. Daily, 365. Let's not discuss leap years. Okay, just use 365 for the number of days in a year. So what ends up happening is our I value, our annual interest rate here, is going to get divided by the number of times we compound in a year, and our number of years, that's going to get multiplied by the number of compounding periods in a year. So make sure you understand. So these numbers, that's the C value right there, and the C value up here and here.